Section 4.1, Scatter Diagrams and Correlation. In this lesson, we will be able to draw and interpret scatter diagrams, describe the properties of the linear correlation coefficient, estimate the linear correlation coefficient based on a scatter diagram, compute and interpret the linear correlation coefficient, and explain the difference between correlation and causation. In chapters 2 and 3, we examined data in which a single variable was measured for each individual in the study. We call this univariate data, such as the 5-year rate of return, the variable for various mutual funds, the individuals. The graphical below measures that we found for univariate data include things such as the histogram or box plot. So graphical summaries of univariate data are histogram, bar plot, and box plot. Numerical summaries of univariate data are the following. So the numerical descriptive measures included things such as the mean, the standard deviation, or the interquartile range. In this chapter, we discussed graphical and numerical methods for describing bivariate data. That is, data in which two variables are measured on an individual. So, bivariate data is data in which two variables are measured on each individual. So, for example, we might want to know whether the amount of cola consumed per week is related to one's bone density. The individuals would be the people in the study, and the two variables would be the amount of cola consumed and bone density. In this study, both variables are quantitative. We present methods for describing the relation between two quantitative variables in section 4.1 to 4.3. Now, suppose we want to know whether the level of education is related to one's employment status, such as employed versus unemployed. Here, both variables are qualitative. We present methods for describing the relation between two qualitative variables in section 4.4. Situations may also occur in which one variable is quantitative and the other is qualitative. We have already presented a technique for describing the situation. Looking back at a previous example, which is example 3 in section 3.5, where we considered whether spaceflight affected red blood cell mass. There, the spaceflight is qualitative. Rats sent to space or not, and red blood cell mass is quantitative. In this chapter, we discuss graphical and numerical methods for describing bivariate data, data in which two variables are measured on an individual. Before we can represent bivariate data graphically, we must decide which variable will be used to predict the value of the other variable. For example, it seems reasonable to think that as the speed at which a golf club is swung increases, the distance a golf ball travels also increases. Therefore, we might use club head speed to predict distance. We call distance the response-dependent variable, and the club head speed the explanatory or predictor or independent variable. The response-dependent variable is the variable whose value can be explained by the value of the explanatory or predictor or independent variable. Objective 1. We want to draw and interpret scatter diagrams. The first step in identifying the type of relation that might exist between two variables is to draw a picture. We can represent bivariate data graphically with a scatter diagram. A scatter diagram is a graph that shows the relationship between two quantitative variables measured on the same individual. Each individual in the data set is represented by a point in a scatter diagram. The explanatory variable is plotted on the horizontal axis, and the response variable is plotted on the vertical axis. So, for example, drawing a scatter diagram. A golf pro wants to investigate the relation between the club head speed of a golf club, measured in miles per hour, and the distance in yards the ball will travel. He realizes that the other variables besides club head speed also determine the distance a ball will travel, such as club type, ball type, golfer, and weather conditions. To eliminate the variability due to these variables, the pro uses a single model of club and ball, one golfer, and a clear 70-degree day with no wind. The pro records the club head speed, measures the distance the ball travels, and collects the data as you can see here in Table 1. What we want to do is we want to draw a scatter diagram of the data. Now, the first part of the column we see club head speed, which is in miles per hour, and then the distance in yards. Now again, because the pro wants to use club head speed to predict the distance the ball travels, the club head speed is the explanatory variable, which is the horizontal axis. So down here on the graph, we want to label our horizontal axis. So here's our horizontal axis. We can see that we're going to go from 0 all the way to 105. The lowest number in our data is 99 in the club head speed. The highest number is 105. So we're going in increments here of 1. And we label this as club head speed. This, again, is the explanatory variable. Now the distance is the response variable, which is the vertical axis. This is the distance. So we're going to label that as the distance in yards. And again, it's going to go from the lowest number of 255 all the way to 280 because our data goes from 257 as our lowest value all the way up to, let's see here, 277. So we're going to go in increments of 5. So now what we're going to do is we're going to plot each particular point. Okay, so we can see here that this first one, 100, 257, this is our first order pair. So we're looking at 100 and 257. So this first point here is going to represent 100 and 257. Okay, our next point is 101 and 264. And again, we're getting that from our data. So now we're going to go to 102 and 264. So here's our next point, which is 102 and 264. Okay, next we have 103 and 274. So now we're going to plot that point. So we're going to go 103 and 274. So here is 103 and 274. Our next order pair is 101 and 266. So here we have 101 and 266. Our next order pair is 105 and 277. So over here we have 105 and 277. Okay, next we have 100 and 263. So we have 100 and 263. So here's 100 and 263. Our next order pair is 99 and 258. So over here we have our 99 and 258 ordered pair. And then the last one is 105, 275. So we have 105 and 275. So there is 105 and then 275. Okay, so again, notice that the axes are labeled and the graph has a title. Okay, so graph's title says driving distance versus club head speed. This helps the reader interpret the information in the graph. It appears from the graph that as the club head speed increases, the distance the ball travels increases as well, because we can see what's happening here. Now, how would we graph this on StatCrunch? Well, let's go ahead and open up the data. So we're going to open up the data in StatCrunch. So here's our data. We can see here's the club head, here's the speed. So if we want to create a scatter diagram, then we would do the following. We would select graph and then go down to where it says scatter plot. We know the X variable is the explanatory variable, which is the club head speed. And the vertical axis we decided is the distance, so therefore that represents the speed in this case, which should be the distance. So let me go back and then change that. So over here, this should say distance. So that might have been error on the computer's part. So let's go ahead and go back to scatter plot. We have our club head for the X variable and then distance for the Y variable. Okay. And now what we want to do is now we want to label our graph. So we know that we want to display the points. Okay. And then down here, we have the x-axis, and the x-axis is the club head speed. So we have the club head speed, which is in miles per hour. Okay. And then we have the y-axis label, which is in distance. And so we know that that's in yards. And then we have the title. And so the title is the driving distance versus the club head speed. Okay, and so now what we're going to do is we're going to go ahead and select compute. And so now we have our scatter diagram, which resembles what we have over here. Okay, and so there are your points. Okay, so that's how we create it using StatCrunch. Now, if I wanted to use my TI84 calculator, what I would do is I would come in here, okay, and then we're going to come in here where it says Stat, and then we're going to select Edit. Okay, now if you already have data in here, we want to clear the data. We're going to go to Second and then select Memory, which is the memory which is above the plus button. And then down number 4, you're going to clear all the lists. So we're going to go ahead and hit Enter, and then hit Enter again. Now we're going to go back to Stat, and then we're going to select Edit. Now for list 1, we're going to put in our values. We got 100, 102, 103, and I'm going to put the rest in. Okay, so I put them all in all the way to 105. That's the explanatory variable. Now I'm going to move to the next list, and I'm going to put in the response variable, which is the distance. So I'm going to put in 257, and I'm going to continue all the way down to the bottom. Okay, so now I put them all in, and now I want to go ahead and I want to graph. So I'm going to hit Second, and I'm going to hit Stat Plot, which is the Y equals button. And then we want to make sure the first one is on. So we're going to select number 1. We're going to hit Enter. Okay, we want to make sure the on is highlighting, so we want to make sure that that's blinking. Okay, so we want to select, there's 6 of them here. Okay, the first one is the scatter plot because it gives you an X list and a Y list. Okay, the second one also gives you a graph, but it's not a scatter plot. So you want to choose the first one, select Enter. You want to make sure you have L1 in the X list because that's the first list. The Y list is L2. Then you have the mark, it just marks the actual value of each point. And then now what you want to do is you want to go to Zoom. So you're going to select Zoom, and then you're going to scroll all the way down to number 9 where it says Zoom Stat, and then press Enter. And then it gives you the same graph that we have over here. So that's the way to do it on a TI84 calculator. Okay, so we did it by hand, we did it by using StatCrunch, and by using the TI84 calculator. Okay, now let's go a little further. Now we have to decide which variable is the explanatory variable and the response variable. It is not always clear which variable should be considered the response variable and which the explanatory variable. For example, does high school GPA predict a student's SAT score, or can the SAT score predict GPA? The researcher must determine which variable plays the role of explanatory variable based on the questions he or she wants answered. So for example, if the researcher wants to predict SAT scores based on high school GPA, then a high school GPA is the explanatory variable. Now, interpreting scatter diagrams. Now, scatter diagrams show the type of relation that exists between two variables. Our goal in interpreting scatter diagrams is to distinguish between scatter diagrams that imply a linear relation, a non-linear relation, or no relation. Now the figures below displays various scatter diagrams in a type of relation implied. If we look at A, this is linear. Here's the response and explanatory. You can see that it's going in a linear situation. It's kind of creating a line here. So you can see here that this is representing a line, which is a linear situation. If we look at B, we can again see a line, but now it's going downward. So that's another linear situation because it's looking like a line. The one for part C, it's creating sort of like an upside down U-shaped. Okay, this is non-linear because it's not a line. For D, you can see that we have, again, another type of shape here, but it's not a line, so it's called non-linear. And then this one, you can see that there's dots all over the place. This is considered uniform, which is no relation. So again, notice the difference between figure A and figure B. Okay, it's going up from left to right, so this is going to be considered a positive relation. Over here, it's going from left to right, it's going down, so this is considered a negative linear situation. Now again, the data follow a linear pattern that slants upward to the right in figure A and a downward to the right in figure B. Figures C and D show nonlinear relations, and figure E says there's no relation between the explanatory and response variables. Now, two variables that are linear related are positively associated when above average values of one variable are associated with above average values of the other variable, or below average values of one variable are associated with below average values of the other variable. That is, two variables are positively associated if whenever the value of one variable increases, then the value of the other variable also increases. So for part A, that graph represents a positively associated situation. Now, two variables that are linear related are negatively associated when above average values of one variable are associated with below average values of the other variable. That is, two variables are negatively associated if whenever the value of one variable increases, the value of the other variable decreases. So for part B, that represents a negatively associated situation. So if we take a look at this scatter diagram that we end up putting together over here to the right, this scatter diagram in the figure to the right implies that the club head speed is positively associated with the distance a golf ball travels because it approximates a positively linear situation. And now note that, remember, the idea of slope of a line from algebra, two variables that are positively associated can be described by a line with positive slope. Two variables that are negatively associated can be described by a line with negative slope.